Here's a sample problem using one of our kinematics equations. So I want you to press pause, take your time to read through this, try to identify the variables, try to pick out the equation, try to plug in the math and do it all on your own. And then when you're ready to go through with me, press play. Okay, so I'm going to kind of read through this and just think about my kinematic variables. I'm going this 12 meters per second when I first get to the intersection. So that might be like a v initial. Then I have this acceleration that's telling me that's definitely going to be my A. And they tell me that I accelerate for 3 seconds, so that's probably my delta T. And the question says, how far do you travel? Well, I don't turn around, so I think I can just use displacement for that. So they're asking me for delta X. So I can say V initial is 12 meters per second. How do I know that that's V initial? Because that's my velocity when I first start to accelerate. That's what my velocity is. Once I start to accelerate, my velocity is going to change, but this is the velocity I have initially when I begin to accelerate. My acceleration is 2 meters per second squared. Delta t is 3 seconds, and they are asking me to solve for delta x. So I really like to write out all the variables that I'm given and write down the variable they're asking me for. Because now that I've identified these, the problem is, a lot of the difficulty in this problem is over. Because now I'm at a point where I can look at my list of equations, of my kinematic equations, and I can say which one of these equations involves v initial, a, delta t, and delta x. And if you look at your list, you'll see it's the second one on the list. It's the equation that says delta x equals v initial delta t plus 1/2 a times delta t squared. So, because I know the value of 3 kinematic variables, I'm able to solve for a fourth. You're going to find that that's a pattern. You always want to find the value of 3 kinematic variables, then you know you're going to be able to solve for a fourth one. So let's plug in the values that we know. I've plugged in here for V initial, for delta t. I've plugged in for A and delta t again, and then I can solve all the math, and I find that delta x is 45 meters. Let's do another one. So again, press pause. This one is not quite as much of a plug and chug. This one involves a little bit more thinking and understanding the concepts. So press pause, read through it, do your best, and then press play to see it with me. Okay, first of all, there's some numbers that are just going to throw you off here. The typical cheetah stride is 8 meters, so you might just real fast write down delta x equals 8 meters. But let's keep reading. They say that the cheetah can accelerate from rest to 18 meters per second in 3 strides. So actually a displacement that takes me from rest to this 18 meters per second, that happens over a distance of 24 meters, not 8 meters. So I would say that delta x is 24 meters. The other thing that makes this a little bit trickier is it doesn't specifically say v initial equals 0. They do say, however, you accelerate from rest. So you have to know that that means v initial equals 0. So I've got my v initial equals 0. I've got my v final equals 18 meters per second because this is kind of representing the period that I'm accelerating over. I go from 0 meters per second to 18 meters per second. Why didn't I use the 40 miles per hour? Well, we want to now stick to our SI units, and they're giving us this distance in meters, so I'm going to want everything to be in meters. Delta x, as I said, is 24 meters, not 8, because they said it happens in 3 strides. And they're asking me for what is the acceleration. So now I have identified the 4 kinematic variables that I want there to be in my equation. And if you look at the equation, you'll see that it's equation number 3. It's the third one on the list. V final squared equals V initial squared plus 2a delta x. And I can plug in all the values I know, and then I can solve for A.